Now let's study application of dimensional analysis. That is, what are the usage of a dimensional analysis? For what purpose it can be useful? That is, the dimensional analysis has three main usages. Okay, three applications. Mainly we have to study in our syllabus. There are three main applications. The first application is first one. It does check the dimensional consistency of equations. Okay, checking dimensional consistency of equations. Second one, unit conversion. It converts one unit into another unit conversion. It can be helpful in unit conversion. And the third one is deriving a relation or deriving a formula, that is derivation of relation among physical quantities. At first we will study the first one. This is number 1, number 2, this is number 3. What is called checking dimensional analysis. Checking dimensional consistency of equations. What is this dimensional consistency? First rule is checking consistency of equation. Let's study this in detail. What is this dimensional consistency of equations? In this rule, we see that every part of the equation has the same dimension. Okay, we use the principle of homogeneity of dimensions to check the consistency, okay, and correctness of equation. This is also used to check whether the equation is dimensionally correct or not. This rule, okay. So dimensional consistency means we can write in this way, all the terms in the equation should be dimensionally same. The main thing is this, should be dimensionally same. All the terms in the equation, either on the left side or on the right side of sign of equality, either in the LHS or RHS, all the terms involved will have the same dimension. This is the rule number 1, that is first application, and this is also called principle of homogeneity. This is also called principle of homogeneity. Very important question arises from this. What is principle of homogeneity? Principle of equations. This rule is also called principle of homogeneity of equation. And that is the checking whether the equation is dimensionally correct or not. This is the first application of dimensional analysis, and in this, how do we check all the terms involved in the equation and find the dimensions of all the terms, and the dimensions of all the terms will be same. Let us see it with an example. Suppose there is a question. This example is, there is an equation, say it is s equals to any equation. Suppose it is s equals to ut plus half at square. We know this is an important equation. We have to check whether this is dimensionally correct or not. How many terms are in this? One term, second term, and this is third term. Okay, these all the three terms will have the same dimension. Then it will be dimensionally same. It means according to principle of homogeneity, this is dimensionally correct. Okay, so first term s has the dimension L only. S is a distance, we know. Second term ut has the dimension. U means velocity, t means time, and velocity means you can express it in t minus 1, and then t is this, so it will be what, minus 1, and this is plus 1, minus plus cancel, so it is single L. And then third term half at square, the dimension will be, this half is a constant, so no dimension, there is no question of dimension here about half. And a means acceleration. What is the dimension of acceleration? L t minus 2, and t square means time square. This and this is plus 2. Here the power is minus 2, so it will be cancelled, and here only L remains. Now we see the dimension of first part is L, the dimension of second part is also L, and the dimension of third part is also L. So this is dimensionally correct, and this satisfies the principle of homogeneity of equations. Okay, so we checked that this equation is dimensionally correct. Okay, because all the terms in the equation have same dimension. So this is the first application, and now the second is unit conversion. For unit conversion, we will see that we remember the formula n1 u1 equals to n2 u2. What is this? Here n1 and n2 are numerical values, means simply numbers, magnitudes before a unit. Suppose it is written 5 meters, then this 5 is a magnitude numerical value n. And what is this? Is meter, this is unit, this is u, this is n. Okay, and what is this u1 and u2? These are units. Now we have to convert one system of unit into another system of unit. For this we will use this formula, which is based on the magnitude is always remains the same. The magnitude of physical quantity will remain the same irrespective of the system of unit. Okay, magnitude remains always the same, and with the help of this formula we convert one system of unit into another system. So let's see how it is done. Let us suppose, if suppose that u1 the dimension is m1, l1 and t1. This is a, b, c, and u has the dimension m2, l2 and p2, and this is power a, b, c. Okay, where m1, l1 and t1 are fundamental units in one system, and m2, l2 and t2 are fundamental units in other system. What is system? Systems we can recall it is it can be MKS, CGS. In this way also we can understand MKS and CGS are two other systems. Okay, so it can be one system, it is another system. Okay, now according to this formula what we will get, we have to convert means finding this n1, n2 we write in this way. Putting these values in this we will get what? n1, m1, a, l1, b, t1, c equals to n2, a, l2b, t2c. And we have to convert one system into another system. So if this will be known, then we will find this one, this numerical value easily. And what will be this? Will be n1 on a, l1, b, t1, c, this by here it is m2, a, l1, b, t1, c. Okay, this, and this can also be elaborated as further explained. It can be in this way: n2 equals to n1, this is m1 by m2 to the power a, and this is l1 by l2 or b, this is t1 by p2 to the power c. Okay, this one, this is the relation. This relation we get, this relation is used to convert one system of unit into another system of unit, and this is by the help of dimension. So it is use of dimension to convert one system of unit into another system of unit. What is the basis of this unit conversion? This formula, and this formula is based on that the magnitude remains the same. This is best what thing? Because magnitude remains same irrespective of system of units, because magnitude remains same irrespective of system of units. Okay, now let's understand it with an example. This is one important question from NCERT book about unit conversion. The question is, a calorie of heat energy is equal to 4.2 joule. What is given? At first we write given items in the question. That is 1 calorie is equal to 4.2 joule, where 1 joule equals to 1 kg meter square per second square. Also it is given 1 joule equals to 1 kg meter square per second square. Actually it is given, it means what? This is the system of unit in which it is given. Okay, the main purpose is to focus on the system of unit. So it is given 1 joule equals to 1 kg meter square per second square. Suppose we employ a system of units in which unit of mass is alpha kg. This is one system of unit, one unit system. There is another system of unit in which another system of unit is also given, another unit system. Here unit of mass is given as alpha kg, unit of length is beta meters, and unit of time is gamma seconds. Okay, this is another system of unit, and in one system of in first system of unit, what is the unit of mass? Here unit of mass will be what? 1 kg. Length 1 meter and time 1 second. As we know, 1 joule equals to 1 kg meter square per second square. The main focus to give this term is to show that this is a unit of system previously followed. Now there is another system of unit in which unit of length is not 1 kg, but it is unit of mass is not 1 kg, but it is alpha kg. Unit of length previously was 1 meter, but here it is beta meter. Unit of time previously it was 1 second, and now it is gamma second. Okay. Now the main question is find the magnitude of calorie in terms of new unit. Now it is the magnitude is 4.2 joule in first unit system, and now the second unit system, that is this, we have to find the magnitude of calorie. Now let's see how it will found. We know that for any physical quantity, the product of magnitude and unit, always remains constant. That is N1 U1 equals to N2 U2 for any physical quantity. Okay. So here we will see. So 1 calorie in this unit will have the same magnitude, and magnitude into unit, and in the second system of unit, the product of magnitude and unit will also be the same, because now here let's see, in first system 1 calorie, and in second system the energy will remain as 1 calorie itself. In the first system we know it is 4.2 joule, and the second system this is what? 4.2. It will not be 4.2. Do you know what? Why this is not 4.2? We have to take N2 in this U2. Okay. This unit we will put it by using this, and we have to find this one, this magnitude. The question is to find the magnitude of calorie. This is the magnitude of calorie here. So using the formula is this. Using the formula, what we will do, we have to find N2. This is for understanding purpose only. The formula for N2 will be N1 U1 by, it is U2. This will be the formula, and we have to simply put all the values here. The value of N1 is what? This 4.2, and U1 means unit 1. Unit 1 is already, it is 1 kg. 1 kg, and 1 kg, and in unit 1 it is 1 kg, the unit is 1 kg, and in system 2 the unit is alpha kg, so it is alpha. Okay. And in unit system 1, length unit has 1 meter, in kg, and The unit of length in system 2 is beta meter. It is beta. And for time it is 1 second. We are putting the units only. It is gamma second as a unit. This is gamma second. Okay. And here the dimension of energy is what? We will consider the energy dimension is, we know the previous lecture it was this. The dimension of energy had a dimension of ml square t minus 2. So it is m this square and t is minus 2. Okay. Now the value will be 4.2. This is alpha will come in the numerator, then it will be minus 1 and beta minus 2, and for gamma it will be plus 2. Upon calculation it will come this one as the answer. On calculating this one it will come to this. Okay. What we did here, we simply arranged units. Here the unit was 1 kg. Actually the unit is what? Here the unit is kg. Kg means what? Kg equals to 1 kg in this system, and in this system kg refers to alpha kg. This is the unit. The unit means the smallest part, which is very preferable for measurement in that system. So it is unit. Unit is written here. Both numerator and denominator, they are both units. This is in one system of unit. This is in another system of unit. We know this is MK system because this is MK system. It is obvious. And this is another system of unit. This is another system of unit. This is another system of unit. And in the same way, we put only system of units. Okay. And then we got the result. Okay. Now the third application of dimensional analysis is deducing relation among physical quantities. What is this term explains? It explains, you can also understand finding formula expression. Okay. Not the exact, but it is similar to exact, not the exact. It finds formula. Dimensional analysis is used to find formula. Let us take an example. Suppose we have to find the formula of time period in simple pendulum. Okay. Let's take an example. How we find out? Find the time period of simple pendulum using dimensional analysis. Okay. Here is the solution. This is a simple pendulum. It moves to and fro. Okay, this is the motion of simple pendulum. What we have to find? We have to, what is given? It is given is simple pendulum. Simple pendulum whose bob is of mass m. This is bob of mass m. Okay, this is given, and we have to find what to find or to derive is time period t equals to what. Now let us see what are the governing factors of time period. This is length L. This is also given. It will be written in given part. That is length of a string is L. Length of a string is also given. Now the governing factors. Time period will be dependent on mass, no doubts. It will depend on mass, but in what way? We will say, suppose m to the power a b c we will take as some unknown powers, not they are known, some unknowns. Okay, and it will depend upon time period will also depend upon length of the string. Time period will also depend on gravity because it is falling and moving to and fro with the gravity and against the gravities. Okay, so gravity is one region of its motion, so it is gravitational acceleration is taken, and whose power, let it be c. Okay, to equate any proportionality, what we do, we simply put a constant k. So t will be equal to k into m to the power a, l to the power b, g to the power c. And now it comes the concept of dimensions. Considering dimensions on both sides, or you can write, yes, you can write considering dimensions or dimensional analysis. The dimension of t will be equal to the dimension of this one. K is a constant, so there is no question of dimension. Okay, then what is the dimension of this t? M will be 0, L will be 0, and T will be 1, because there is only one here, one quantity, that is time, and here it is. We will omit for some time. It is m to the power a, l to the power b, and g is what? Acceleration, so it is lt minus 2. C will come here. Okay, in this way. If we expand it, it will be m a l to the power b plus c t to the power minus 2c. It will be this, in this way. Now equating, we get what? A equals to simply 0 minus 2c equals to what we get? 1. This implies c equals to minus 1 by 2. And also we equate this term, this m to the power a, here it is m to the power 0. So it is a equals to 0, and t to the power minus 2c, t to the power minus 2c here, and plus 1 here. So the powers will be equated, minus 2c equals to 1, and c value will be calculated through this, and the power of which remains L, then b plus c will be equal to 0 also. B plus c will be equal to 0. putting C in this equation, we get B equals to minus C, that is minus plus 1 by 2. Now what we do? We substitute. Last step is substituting. So we will substitute all the found values of A, B, C in this equation. This is, let it be equation 1. In this equation, when we will put, what we will get? T equals to K m to the power what? M to the power A, it is A is 0. L to the power B, B is L to the power B means L to the power half, and G to the power C, C is minus 1 by 2. Okay, we will get this as an expression. If it will be solved clearly, it will come to what? It will come to K. This means what? This will be m to the power 0 means it is 1. No need to write 1 in the product. Okay, no need to write. So m goes out, and L to the power 1 by 2 means under root L. It is under root L, and G to the power half means divided by under root G, which will be equal to what? It will be equal to K under root L by G. Derived. Thank you. So here we see we can derive any formula using dimensional analysis. What are the steps we followed? At first we written the given items. Here the given items will be here in this case it was a simple pendulum given. We taken the mass m. Obviously it will depend upon length of the string also. So all the governing factors, we collected all the governing factors, that is mass, length and gravitational acceleration. These were the governing factors. So we written T is directly proportional to this. Okay, and to equate it, because we have to find the formula expression, so to equate it we multiplied a constant here. This is this. In dimensional analysis, constant has no meaning, means there is no dimension of constant. So considering dimensional analysis, what will be dimension of this part will be equal to dimension of this part. Okay, because the theorem says dimensions of every term of any equation is same. According to principle of homogeneity of equation, we already learnt it. This, the dimension of this part is this, and the dimension of this part is this, and rest other is simply calculation and nothing else. We simply looked at the governing factors. We simply utilized principle of homogeneity of equation, and rest one is simply calculation, nothing else. Only 3 steps: governing factors, dimensional analysis, that is principle of homogeneity of equation, and then calculation. Okay, thank you.